Assalamu alaikum dear student, welcome to the class physics. Dear student, today our topic is application of Gauss law. So before starting this lecture, we want to distinguish or recognize what was Gauss law. Let's suppose we have a closed surface. So how we will find the electric field intensity or the electric flux of that closed surface? According to Coulomb, if we have a closed surface or we have a field which are not uniform, so we will divide it that closed surface is n number of paths. First we will find the electric flux of every path. After that we will take the summation, so that will be the electric field intensity or the electric flux of that closed surface. A scientist come, his name was Gauss. Gauss told, if we have a closed surface, so we will not need to divide it. That closed surface is n number of paths. We will divide it. How many charges in a closed surface divided by that is medium. There is a medium between or among many charges. So, dear student, according to Gauss law or according to Gauss, electric field intensity is zero inside a conductor. Why electric field intensity is zero inside the conductor? Because there isn't any charge. Every atom is neutral. So if there isn't any charges, so there isn't any electric field lines. If there isn't any electric field lines, so there isn't any electric flux. If there isn't any electric flux, so the field is zero inside the conductor. So electric field intensity is zero inside the conductor. Outside we can take, but inside the electric field intensity is zero. Dear student, we have today our application is electric field intensity due to infinite sheet of charge. Due to infinite sheet of charge. Let's suppose this is our infinite sheet of charge. Surface is 1, surface is 2, surface is 3, and surface is 4. And the electric field line removed toward you. Toward you. The direction of this surface and the direction of field lines same. So the angle between the direction of this surface and the electric flux is zero. And the direction of this surface is upward. And the direction of electric field lines toward you. So the angle between the electric field intensity and this surface area is equal to zero. Also the direction of this surface area toward you and the direction of electric field lines also toward you. So the angle between the direction of electric field lines and the surface is equal to zero. And the direction of this surface area up and the direction of the electric field lines toward you. So the angle between the direction of this surface is end and the electric field lines is 90. So dear student, this is infinite sheet of charge, and I show you practically. This is surface S1, which is the direction of surface, and the electric field lines both are same direction, and this also. This and this both are perpendicular each other. So total charge is equal to Q. Total charge is equal to Q. Surface area is equal to A. And charge density is equal to sigma. So sigma is equal to charge per unit area. Charge per unit area. So charge is equal to sigma A. This is our equation number first. And according to Gauss law, how we calculate the electric field lines? So total flux is equal to total charge divided by epsilon naught. Epsilon naught is the medium between or among charges. So total, we will take only the left side of this equation number first. Pi E total flux is equal to flux of this area, this area, this area, and this area. So total flux is equal to pi 1 plus pi 2 plus pi 3 plus pi 4. So S1, surface S1 and surface S2 we will use, and the remaining two surfaces are equal to 0. So pi 1 is equal to E dot delta A1, pi 1 is equal to E dot delta A1 cos of theta. So here the angle between the electric field lines and the surface direction is 0. So pi 1 is equal to E delta A1. So pi 1 is equal to E delta A1. Pi 2 is equal to, similarly we calculate according to this rule. Pi 2 is equal to E delta A2. Pi 3 is equal to 0 as well as pi 4 is equal to 0. So pi E is equal to E delta A plus E delta A. So pi, this is also surface, A1 is also surface, A2 is also surface. So without subscript, we can use. So 2EA is equal to Q divided by epsilon naught. Now E is equal to, so instead of Q, we will use this value. Q is equal to sigma A. So sigma A, E is equal to 2EA is equal to sigma A and divided by epsilon naught. So A will cancel the A. So E is equal to sigma divided by 2 epsilon naught. Electric field intensity is a vector quantity. So we will use in the form of direction. So E is equal to sigma divided by 2 epsilon naught into R. Dear student, if you like my video, so like my video, share my video, and do study. Wish you best of luck.